All right. Let's see. So you put a couple of problems on the board that you wanted me to do a couple of videos for, and I shall do that right now. All right, y equals this is 2 log base 3 of x plus 3 plus 5. And I will be asking you to find x-intercepts and y-intercepts. And in this case, I think I asked you a y-intercept. Well, there's something true about values on the, and I'll just do the integers. 0, 1, 0, 2, 0, 3, 0, 4, etc., 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 and also in the negative direction. There seems to be a pattern here. Can you see what the pattern is? I hope so. You use the number 0. And in math, sometimes we like to think of that, especially in exponential function, making a zeros an initial amount. So we'll plug 0 in for x. That gives us 2 log base 3 of 0 plus 3, which is 3 plus 5. Everyone in the class is capable of doing the most intellectually challenging part of that is taking that logarithm. So 2 times 1 plus 5, what was the y-intercept? 0, 7. And so I'm going to try to give you functions that aren't quite as familiar to you. I'm going to say, what's the y-intercept? So I might give you something like y equals minus 2, x minus 3 squared plus 4. You pause the video and you find the y-intercept. All right, so I like plugging 0 in. If I plug 0 in, I get minus 2 minus 3 squared. Board here, plus 4. That's minus 2 times 9 plus 4. That's minus 18 plus 4. Looks like a 0 gets me negative 14. Now, that's helpful. I like to work with 0 a lot. So if the vertex was 3, 4, we can see the vertex. All right, how do you get from 4 to negative 14? You go down 18. 3 to 0 squared is 9. Well, you can see where the negative 2 is coming from now. Very helpful, y-intercept. So let's see, it's another one. So that was a quadratic log. Let's do an exponential. Y equals 5, 2 to the, let's see, x minus 3 plus 4. What are we going to do? We're going to let x equal 0. And we're going to see if we can figure out how to calculate. Well, 2 to the negative 3, we've been working on that. That's 1/8. You can see this, yes, plus 4. Well, that sure looks like 4 5/8. That's what I get for an amount if I plug 0 into the original equation. All right, so what's another one? Let's see. Maybe I can do cosine. 2 cosine of 3x plus 5. And I want the y-intercept. The y-intercept says that I know that x is 0. So that gives me 2 cosine of 3 times 0 is 0 plus 5. I have to do the intellectually most challenging. Cosine of 0 is over there. Oh, that's 1. So 1 times 2 is 2 plus 5. Looks like the y-intercept, if I put a 0 in, is 7. So you actually have to work with the number and see where it takes you. And I think you've got all the skills necessary to answer that. Is there another one I can think of that might be interesting? Sure. We'll do an absolute value. Y equals 4, 2, x minus 8 plus 17. I want the y-intercept. Let x equal 0. That gives me 4 times the absolute value of negative 8 plus 17. That gives me 32 plus 17. That gives me 49. So that's what I get when I put a 0 in. So what did this graph look like? It's very helpful to get the y-intercept. I hope you can see if you put a 4 in, you get 17. And it's a V shape up. There's your 4, there's your 17. And a 0 gets you 49. 0 gets you 49. That's quickly graphed and it's graphed correctly. If I add some arrows at the end, it gives it a better look. Except a little crooked there right now. But that's all I expect. If I give you an absolute value is the vertex and the y-intercept, and then you've got yourself a nice graph. 17 to 49, you can learn some things. It's 33. Did I make a mistake here somewhere? Let me check. I didn't like that answer, 42, 49. Okay. So 49. Oh, yeah, I just added that wrong, I think. So 49 minus 17, 30, 32. Yeah, so the change in y is up and down 32. And the change in x is 4. And 4 divided by 32 is 8. So the branches, this one's going up at 8 to 1, and this one's going down at 8 to 1. Those are the two branches following down, then up. Why did I do that? Because that's the slope of the branch. And now you look back at the original equation and, well, what do you learn from that? If I want to know how this is changing, then I guess I got to do a little multiplication here. 4 times 2. And you can, learn a little bit, deepen your understanding a little bit of that calculation. All right, so that's what that was. Then I gave you a factoring problem. And it involved the sign of x. So what is the sign of x? Well, it's a calculation. And if you put something in, you get something out. What do you get out? You get a fraction out between -1 and 1. All those nice numbers, 0, 1/2, √2/2, √3/2, 1, -√3/2, so on and so forth. All right, those are the numbers you get. So the sign of x you can think of as a number. And I asked you to factor sine squared x minus 4, which is a fraction squared minus 4. Does it look different when I ask you to factor f squared minus 4? Sure, it's a difference of 2 squares. It's the function +2 times, the fraction +2 times the fraction -2. And what did we say the sign of x is? The sign of x is equal to a fraction. It's small numbers between 1 and -1. All right, so what do I write? Sine of x +2 times the sine of x -2. And that's the factored form for this. So I can give you some other ones, see if you can factor. All right, trigonometry can be solved by factoring. A lot of equations can be solved. So what if I give you the tan squared x minus the tan of x minus 6? You see if you can get a product. And I'll just keep going. Well, there's only one way to get tan squared x. It's tan x times tan x. Now, there's a bunch of different ways to get 6, but I want to be 1 apart. Well, that brings to mind the numbers 2 and 3 to me, and I want it to be negative. So there's -3. There's +2. I think -3 times tan x is -3 tan x. I think +2 times tan x is +2 tan x. I think tan x times tan x is tan squared x. And I think 2 times -3 is -6. Well, we can immediately see tan squared and -6, right? And the question is, -3 + 2 of the same thing, -1. Hopefully you can see how that's done. All right, what's another one? Let's see. What's another one? Let's try cotangent squared x -9. Pause the video, you try it. I hope you're starting to see cotangent x +3 times cotangent x -3. I'm hoping you're seeing that. Can I think of another one? Let's see. Yeah, we've got our 2 sine squared. No, that's not what I want to show. Do I? Let's just try sine squared x -2 sine x -15. Right. Again, you can always think of the sine function as you go around the circle as a y. So you could have looked at y squared minus 2y minus 15 as a clue as to where to go with this. So I hope you would see that you have y minus 5, y plus 3 with a little bit of practice. So what was y standing for? The sine function. So I've got the sine of x minus 5 times the sine of x. What's that, plus 3? And we can see the interchange here gives me the -2. The multiplication gives me the minus 15. The multiplication gives me sine squared x. And this could be helpful if we said equals 3. So the sine function is numbers between +1 and -1. This answer is 5. Therefore, there is nothing coming from that parentheses. This answer, for the same reason, -3 is not in the range of the sine function. So I can't make a 0. And factoring helps us see those conclusions. All right, we got one more, two more. All right. Now, I don't think I've actually covered circles with you much. So I'll do that right now, and then we'll do 5 tomorrow on, I think, rapid fire, just to get you started. You've been doing trigonometry. You've been working in a circle, and the center of that circle is 0, 0. And you've been drawing triangles, and you have been taking y values and x values and the number 1, and you have been using Pythagoras. And it's 1 squared, by the way, although we never write it that way. So that's what you're doing. You're taking these square areas, just studying the Pythagorean theorem, really. So what's the difference between the one I gave you? And it brings us right back to an original discussion that we had probably day 1 or day 2. I gave you x squared plus 8x, which geometrically is x times x plus 8. Well, that's not a square. So we have to make it a square. We have to look at x squared plus 8x, and we have to do the old a, which is 1 in this case, x plus 4 minus b over 2a minus 4, so x plus 4 squared. I'll erase the a term because it's a 1. And 4 squared is 16. I don't see positive 16. So that's just putting it in graphing form. If you put -4 in, you get 16 minus 32. And if you put 16 minus 32 together, that's another way to get that. I like the Y-intercept method. That's what I prefer. I know that x squared plus 8x. If I put a 0 in, I get a 0 out. And if I put a 0 in here, I get 16. Getting rid of that 16 means that this calculation is the same as that. If we put a 0 in here, we get 0 plus 4 squared minus 16. So there's your y-intercept. 16 minus 16 is 0, 0. So that becomes 0, 0. It's the same calculation. If you put a 1 in, you get 9. If you put a 1 in, you get 25 minus 16, which is 9. Same calculation. So I guess I'll do 4 or 5 in a row here. Won't hurt just to see what's going on, and maybe you can, by the end of the 5th one, you'll be a pro. So y squared minus 4y equals, and I will layer this with some conceptualization. After you get mechanically sound, I'll dig deeper into it, and we can talk about what's going on and why. All right, so what do I see? You pause the video. I'm just going to do 5 in a row here. All right, so I can see x plus 4 squared. I even off the sides. That produces 16. It's not there, so minus 16. And over here, I've got y minus 2 squared minus 4 equals 5. So that's going to be x plus 4 squared plus y minus 2 squared. And 16, 20, 25 over here, which is 5 squared. So the center, -4 makes a 0. Positive 2 makes a 0, and the radius 5 units. Okay. And I hope you can see that if you put -4 in here, all right, that gets rid of this, so you can find what goes with this. And I hope you can see a 7 or a -3 both work. Minus 3 minus 2 is minus 5 squared, that's 25. So it allows you to see a couple of values here. Where am I? X plus 4, so negative 4, positive 2. And I'm just going up from negative 4, positive 2. Going up 5, going to the right 5, going to the left 5, going down 5. What did we do? We looked at 7, comma, so oh, that's a y value, sorry. So this is a height of 7, and then it goes down to negative 3. And I hope you can see that from 2. If you go down 5, negative 3, and if you go up 5, 7. All right, now I'm just going to do 3 or 4 in a row mechanical. I'm not going to talk about the conceptual. We'll deal with that later. So I just make up some new ones. So let's go x squared minus 10x plus y squared plus 8y equals, let me get you something nice, 25 and 16, 30, 41. Let's go with 8. All right, I'm just going to do it. X minus 5 squared, evening off the sides. Y plus 4 squared, evening off the sides, getting rid of the number that wasn't there originally, equals 8. So that gives me x minus 5 squared plus y plus 4 squared equals 49. So what's the center? 5 comma negative 4. What's the radius? 7. Obviously, I'm taking the square root over here so that it looks more like a Pythagorean relationship. You talk more than I said I would. Next problem. Let's go with x squared minus 2x, make it plus 2x plus y squared minus 4y equals, let's get something nice, 1, 4, 5, 5, let's do 11. Okay, so that's x plus 1, evening off the sides, getting rid of the constant. Y minus 2, evening off the sides, getting rid of the constant after it's squared, equals 11. Bringing the 5 over to the 11 makes 16. Center. Negative 1, 2, radius 4. Another one. Let's do x squared minus 20x plus y squared plus, I don't know, 2y equals, let me think of something good, 101, negative 1. Let's go with that. So I'm going to even off the sides, getting rid of the constant generated because I don't see 100 up there. I mean, if last one I'll do here, if I did this out, I'd get x squared minus 20x plus 100, right? But that's not what I started with. That's what I started with. I didn't start with this. I started with that. So that 100's got to go bye-bye. All right. Plus Pythagorean relationship, even off the sides. Minus 1 equals negative 1. Well, I can cancel the negative ones. And I can move the 100 to the other side. And since I got an eraser, that's what I'm going to do. And I hope that you can see the center and the radius. Center, 10, negative 1, radius 10. All right, that gets us started. That's one of our last problems that I'm going to put in front of you. You're going to get about 7 or 8 tests, which give you about 17 or 18 class days to use to your advantage. I hope you can get that done in 17, 18 practice days. Last problem. All right, solving for h, or solving for x. That's the graphing form for a parabola. And I want to solve for x, means I want to get x alone. All right, so what if I said a was 2, h is 3, and 4 equals 0? I would just solve that. Well, I would hope you would take 4 away. I would hope you'd divide by 2. I would hope you'd move the equal sign so there's some room. I would hope you take a square root plus minus. In this case, there's an I. In this case, yeah, that negative pushes that out. All right, but we got to be careful with this in a moment because it's not the case here. That's the only thing that's different. And of course, then once you get rid of the squaring, you bring the 3 over. So what do? We move the k over. Boom, 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 gone. We move the a over. Boom, 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 gone. We hit it with a plus minus square root. And I can see why you're moving I. I've taught you to do that. I see that, but we really don't know if this number is positive or negative. Right? We really don't know that. So if this was negative 5 to begin with, then when I move it over, it's actually positive 5, the opposite of negative 5. All right, so you don't actually have the right to pull an imaginary because we just don't know this value. If k is negative, this is fine. It's not imaginary. If k is positive, then minus that positive. Yes, you'd need an I. So you'd have to leave it like that. And then the last thing you do is bring the h over. Right. So all we're doing is figuring out what to isolate and what order of operations we have to perform to isolate. So let me see if I can think of another one. E equals mc squared. What if you wanted to solve for m? Pretty easy. All you do is divide by c squared. Right? I mean, basically, I said 20 equals 5 times 2 squared. And I said solve for 5. Well, I hope you'd say 2 squared is 4. And then I hope you divide by 4. So that's fine. If I ask you to solve for c, well, then you got to get rid of the m first. We got to do a little division. And if that's c squared, not that the physics of this is true. When I do plus minus, I haven't thought about that at all, the plus minus, but mathematically, you'd need a plus minus on this side. Right. So let's do an absolute value. Do I want to do an absolute value? No, I don't think I do. I'll do let's just do a cubic. I think this was on the test maybe. 2x minus 3 cubed plus 4 equals 10. Something like that. How would you solve that? Especially if I started with a, x minus h cubed plus k equals z. We'll make it z. All right, and I'm trying to solve for x here. All right, so what's the first step? Subtract 4. So what's the first step up here? Z minus k. Gone, gone. Next step, divide by 2. Divide by 2. Gone. Divide by a. Gone. What's the next step? Undoing cubing. That's cube rooting. Now, cube rooting does not have a plus minus in it. Odd numbers, no. Reason being, if we look at y equals x squared, equaling a constant, yes, there's 2 x's. Odd functions don't behave that way. When I get the same constant in, there's only one intersection. So we don't have a plus minus when we do cube roots. Cube root, in fact, the cube root of -8 is -2. Be down here. All right, cube root of -8 is -2. So no plus minus on that one. And that took care of the cubing. So up here, I got to take the cube root. That takes care of that. And the last thing I got to do is add 3. The last thing I got to do is add h. Right? And that's working with the process. Most equations are solved using inverse operations, and that's just making you perform those inverse operations. All right, so I hope that's enough. I got to be moving on here, and I will stop the video. And in class tomorrow, I've given you the same test as a worksheet, and you're going to work in pairs or groups of 3, and you're going to go from problem 1 through the test. If somebody gets the problem wrong, someone in the group's going to show that person how to do it. All right, and you're going to work your way all the way through the test. Comprendes? All right, see you tomorrow.